All right. So, thank you for coming. Today we are going to talk about this project Trappist that we was around, for a couple of events already. So this is me. I'm Hector. This is like a version of me on 10 years ago. I was not brave enough to change the photo. I will do it eventually, I promise. But yeah, it's still something in my list. So, kind of introductory, right? Introduction. What is Trappist? Trappist is like a toy project like we started in our team, delivery services. So basically, we needed like, a parachain runtime to test, cross-chain interactions, right? Like, of course, with XCM, we tried XCM be-free. And for example, here you can get the repository. The QR for the repository is on the Parity text. So if you check for Trappist, it's there. And this would be like the third session or fourth session, because there is another one in the other builders room. But the very first one started with Steve presentations about like how to interact or your first steps with XCM. I mean, this was a very enlightening presentation for all of us that we needed to build the mental model of XCM. And then the second presentation, it was in previous Sub0, when what we tried to do was to implement, an advanced use case, right, using XCM. So, kind of a disclaimer, right? Trappist is not intended to be like a production-ready parachain or project. So, please don't get the parachain runtime and just bring it to your own project, right? But it can serve as an inspiration. And why we say that? Because there is an initiative that we are working in the team, which is called the Parachain Extended Template, okay, which is kind of a production-ready opinionated template. And we say opinionated because we put on it like functions, right, like in a way are defining the purpose of your chain. Like, for example, one of the parachain templates is an EVM one. So it's kind of a frontier parachain. Another one is like coming already with the assets palette, and pallets like lets you handle digital assets, right? So that's the reason why it's opinionated. But the purpose of Trappist as a project, is to test all those good practices and bring it into the, this extended template. So if you need to build your own parachain, for example, you just grab these templates, which has already a lot of work already made for you, okay? Let's talk a little bit about like what we try to test or what is the architecture of this solution. So we first run or we connect the parachain into Rococo, okay? The idea is to leverage all the utilities that we have in the Asset Hub, right, as a reserve. And in the Trappist project, we have two runtimes, Trappist and Stout, okay? So Stout is kind of a pen pal, runtime that we have for playing as well with different interactions, okay? So Trappist started as a local chain. So basically, easy, we just grab ZombieNet, we basically start all the network, right? Very fresh from scratch. And what this means is we don't have persistent data. We don't need to deal with runtime upgrades or storage migrations. So if the chain stalls, was perfect, what do we do? Control-C, up, start again. My life is great again, right? So beautiful, beautiful feeling. And of course, DevOps off. ZombieNet, right, for the win. Like all those efforts were done by ZombieNet. But if you need to run a live chain, you have persistent data, you have to coordinate the runtime upgrades, you need to ensure storage migration not only for your pallets, but for frame and system pallets are included in your runtime. You need to have a proper testing and release strategy, and of course, you require DevOps, services. Thanks to the Parity DevOps team, for helping on this. If you start checking the differences about a toy project, and a real life chain, you realize that there is a lot of complexities that you don't have to deal with. And when you say, okay, what are the steps required to be a live chain? It's changing a lot your mental model. So we said, okay, let's go into make Trappist a local chain, a testing local chain, to a live chain. So what we try to do is we replicate like the production deployment, right, into Rococo, which is still a testnet, right? Let's be fair, this is not like a production, there is not real money. So if something happens, okay, but what we try to do here is to say, okay, let's pretend like we are a production parachain, so we get all the learnings from here, and of course, all these learnings, we put it on the, on these extended templates, or like we share the knowledge with everyone, okay? So this is kind of all the things, all the topics, all the deployments, like stages, like we went through it, right? Remember, this is like kind of a lessons learned from, from this deployment process, of this process for, turning a local kind of advanced runtime into like a living chain, right? So some of the initial decisions that we said, okay, what do we need to do, right? Yeah, we have a pretty fancy runtime, and now we need to make it live. The first initial decisions was to which release we were going to pick. So this started at the beginning of the year, right? So we chose this release. Why? This release contains the XCM v2 and the weight 1.5, which was still like running the previous version of weight, but we wanted to experience, right, the live migration to XCM v3 and the weight v2, which came in the release 42. Something like you need to start dealing a lot when you have like a live chain is like releases, right? Polkadot releases. Now it's Polkadot SDK releases. Tokenomics, simple, 10 million hoops issues. So we have root with 1 million hoops and 6 accounts with 1.5 million hoops. So just for the records, I would love this to be like real money, but it's not, right? So I have the keys, but yeah, it's a toy, token. Fixed supply, no inflation or deflation. We didn't think too much about this because it's still a testnet. So in case we wanted to like test, like, let's say, a complex tokenomics, we could do it, but we just like making it simple, 10 million of total supply. But we wanted to test something which was the 80% of, sent to the Trappist treasury and 20% of block authors, okay? So for doing this, like, let's go through some code, part of the code, just to refresh where all this comes from. In the chain spec, you can define here your accounts, and you define like the initial balance, right? This is kind of already known by a lot of like developers, but yeah, it worth to refresh on this. And what about configuring fees, right? You need to like rely on some times and implementations, like for example this on imbalance and negative imbalance. So first you define your negative imbalance like this, right? This comes from the currency trade. Then you also define the to author. This basically lets you, get who was the block author for that block, in this case the collators, okay? And then, thanks to that, you can rely all these types, you can like relate it with the deal with fees, right? So basically, this is how you basically split or define from where you wanted to send your fees. So the deal with fees has this implementation on the on-balance sheets that basically lets you split the 80% and 20% of how you want it, okay? And then you can see in the last section, like you split the 80-20, right? So the 80 goes to the treasury and the 20 goes to the author. So if you need to like make like a fancy rule for like, playing with your fees, yeah, this is the way. Also in the pallet transaction, there as well the deal with fees. You provide your implementation there. So thanks to this like, combination of types and the pallet transaction payment, you accomplish this, right? Ways to fee, something like we realize is like this struct, which is the way to fee, gets the ways defined from your pallets, and that transforms that in a fees, right? And the ways v2 basically has proof size and rest time, right? So we have like the two values right now. And from the system chains, we got like this implementation where you have like one polynomial function for the ref time and another one for the proof size. And I think it was like right here, yes, like basically you're having, if you see here, like the time poly, you having the evaluation. The one which is bigger is the one that is prioritized for charging in the fees. Governance, OK, we made it kind of easy because we needed to make it operative. We are relying on the Parity Pseudo, and with 2/6 threshold. And also, the pseudo, the account, right, the root key for pseudo is like a multi-sig account, like basically we owned, and that's how we do the runtime upgrades and so on, right? So the next step to replicate like a real, let's say, parachain or live parachain would be to remove this pallet, remove pseudo, and implement like a governance model with adapts to our needs. That would be like the decentralization, right? Of course, like we are not planning to like say or deploy OpenGov in Trappist. That would be like killing and overwhelming, of course. What about the pallets, right? Which like, pallets we said, OK, we are going to put in our runtime. So coming from initial decisions, the next decisions we took was pallets. And these are all the pallets like we have, like the assets. We had the uniques, like soon we are going to migrate into the new NFT palette. Yeah, basically collectives, treasury, yeah, they are kind of known, right? If you are like developing in Polkadot or Frame, you kind of know them. But we created two customs, OK, pallets that we needed for our own purpose. So the first one is the lockdown pallet. This basically allows you to stop all the operations, right, on the chain. So basically, you can filter any like messages coming from the DMP queue, and also like it stops all the transactions. So basically, you can whitelist or blacklist transactions from pallets, right? And this was kind of useful because when we launched Trappist, basically we launched it with the lockdown pallet mode on, so basically no transactions. So basically we launch and we say everything is cool, and when we feel like safe, we remove the lockdown, filter, and we enable operations, right? So we were trying to think, OK, what would be like a real, deployment use case, like makes us feel safe during the deployment? OK, some parts of the code, like we have like implementations on the lockdown mode palette, and we put it on the base call filter, OK? And also on the DMP message handler, we have another implementation that filters the messages, right? Something that I wanted to mention as well is that we are planning to decommission this pallet, and we are going to use the transaction post and the safe mode, right, that are going to be included on Frame. No, I think it's included already. So yeah, we need to basically turn down this pallet and implement these two new like pallets which came from Frame, OK? The asset registry palette is another one that we needed, and basically this allows you to map like XCM multi-location with a local asset ID and the same way around, right? So basically, when these XCM messages arrive, we map that asset ID one, right? So let's suppose that I have on the asset hub a stablecoin, right? And when that message arrives, we map it with a local asset ID. OK, this is one implementation on that, how would we basically do the magic, OK? I'm sorry, like I don't have the time to go line by line, but you can get like the flavor of how it looks like, OK? So basically, in the fungibles adapter, with all the pallets code logic, you have this implementation, and then you provide it as asset multi-location, and you provide it here in the fungibles adapter. This, of course, goes on the XCM config file. Oh, yeah, this was a big one. No refactoring, OK? So we came from decisions palette, and then when we tried to have like a stout runtime and Trappist runtime, we realized that the node was not ready. So you have the Parachain template. It works great, right? You get the Parachain template, you run it, perfect. You don't need anything. But it supports only one runtime. So if you want to have like two more runtimes, like you need to basically change a lot of things in the code, like for example, the service file, service.rs file, and the command.rs file is just supported only one runtime, okay? So there is a function in the service file which is called new partial that looks like this from the template, and for supporting more than one runtime, it looks like something like this. You need to basically apply a lot of train bounds, okay? Like, because the runtime API types, when you have different runtimes, are different, right? So you need to basically constrain that. And believe me, it's like a lot of code like you need to change on the service file, okay? Thankfully, in the system chains, that implementation was already done. So I got the inspiration from the Parachain, Polkadot Parachain binary. So yeah, that's where we got it. For example, you provide like you have to provide a custom like import queue, okay? And yeah, it's very much different of how it looks like in the Parachain template. Also, we optimize the builds, right? We put like futures builds, right? With Trappist runtime. So in the in the deployment on the CIs, we just like compile the Trappist runtime. We don't like build all the runtimes because basically we don't need it. Also, we rely on Rust workspaces. So we have to basically redefine everything to define all the imports on the workspace, and then we import it on the different like crates we needed, like the runtimes, the nodes, and yeah, it's such as simple as doing this. I mean, I super recommend you to do this if you have your own like project. XCM configuration. This was another big one. So we have the node ready with the 2 runtimes and the pallets, right? So as Trappist is intended to be like a XCM playground, XCM configuration is a big stuff, right? A big thing. So first, we define the asset hub as a reserve, So this is the way we do it. We basically implemented a constants per trade. And what we do is basically we provide the asset hub location as a multi-location, and we recognize like, the asset hub as a valid reserve of assets. So, for example, if you see, you see here we have the reserves and we have the native asset, that comes from the template, and the reserve assets from, okay? So then you define your isReserve type on the XCM executor, and yeah, ready. But also, we are using the asset hub as a trust teleporter. And why is that? Because for transferring your Parachain native token, you need to do it with a teleport, right? Because we trust the asset hub as an extension of the relay chain. But if you want to have more details about it, there was another presentation coming in parallel in the other builder space. So yeah, you can watch it like, you can watch the recording if you want to have more details about how we do it. The traders, so when a message arrives, you need to say like a way of how you pay the fees, basically. We kind of making it simpler or use like the simple way by using the fixed rates of fungibles implementation. I realized that this fixed rates of fungibles is saying, okay, this fee per second, we put like a relation, right? So basically, it's a fixed amount. So it's not like, being calculated in the row, right? But doing an analysis, we saw like a lot of parachains were basically doing it like this. So I said, okay, we have like an stable coin we define in the asset hub, and then we also put the value for the relay chain token, which is in this case is ROC. Okay, then of course you provide the traders on the XCM executor config. But one of the things like we wanted to do as a next steps is to replace like the implementation of fixed rates on fungibles with the take first asset trader that takes the first asset and pays the fees with that. Actually, if I'm not wrong, in the asset hubs it's like that already. Or we wanted to like experiment with our own implementation for the asset trader. Barriers. So this is quite a new one. Like we are using the trailing subtopic It's like related to this new set topic instruction that there is around. Also, like we put the with computer origin, and yeah, this is kind of allows, to make all the interactions like we need it for our use case. Benchmarking, this was a good one. So, benchmarking is a huge topic, okay? I recommend you to spend time on this because, okay, this is the path, we know it already. We have to basically from benchmarking, we needed to do like a lot of analysis on basically, what we need to bring to our parachain to run benchmarking, like how are we going to do it, how we were going to calculate the benchmarking, or how we were going to implement it in our CI pipeline, okay? So it was a huge topic, benchmarking, because once you have your release ready, you need to run the benchmarking, you calculate all the new weights, okay? And you need to do that in every release or in every runtime upgrade, let's say, okay? So first thing we did was to say, okay, XCM, how do we basically charge, right? Or how do we basically calculate the weights? So there is a Pallet XCM benchmarks, okay? And you can benchmark instructions by execution to script version. This is the generic one. It's composed by 2 files. And then you have the fungible one, where all the instructions related to assets, like withdraw assets or receive teleport assets, is included in this benchmark. So this is a way how we implement it. I'm running a little bit out of time, so I will go a little bit faster, sorry. But watch out, this was an important one. If you don't define in your benchmark code, in the runtime, the types don't match, then, for example, in the trust teleporter time doesn't match with the isTeleporter XCM config, then when you run the benchmark, you are going to, in this code, you are going to have something like this in the results of the weights, okay? So when you do the benchmark for this, using this Pallet XCM, you don't match the teleporter types, as this is an example. What happens is the benchmark skips that and puts the max block weight, right? So basically, this is a way when you put isTeleport and you put it with nothing type, with the type nothing, the benchmark, what it does is put the max block weight, so any instruction coming, charge it with the max block, so it says too expensive. So if you receive the XCM message too expensive, it's sometimes because of this. All right, so this is how do we then, once you have the weights, you put it in your wager type in the XCM config. And another important thing is the benchmark overhead command, right? So the overhead command is that execution, or that that we say that weight, which is the base weight, right? Every time you execute a simple extrinsic, okay, that simple extrinsic, even if it doesn't have too much, computational consuming, it needs to come with a base fee, okay? And that comes from the benchmark overhead. So it works again, you need to basically build your very simple benchmark that will be served as the base, weight from your system. And basically, yeah, what we did was to build a remark. We get the simplest remark, which is an empty remark. We benchmark that. And with that, we basically calculate the base fee from, or the base weight from our system, okay? Then you have to define your inherents. I will share then the presentation, and you can get the code there, or you can go on Trappist and see how this is done. So, Polkadot Releases, all right? We have the benchmark, we have everything ready, but in a way we needed to think, how are we going to upgrade to the next versions of Polkadot, right? And hopefully, we have this process now, which is the Polkadot release analysis process, which is a report that is coming in every Polkadot release. So you can go on the forum and get like these reports, and you can see what's going on, right? And this is kind of helpful for when you need to do the upgrade and you have like breaking changes. You can go there and see all the analysis with code snippets and so on. This was like super helpful. Another thing like this interesting and you need to pay attention is like what happened with the storage migrations from the frame pallets or system pallets. There are a lot of times, like there are like, for example, in XCM, there was like a migration, right, that needed to be included. Yeah, I don't know if everyone was aware like that migration needed to be included, right? So hopefully as well we are going to add that in the release analysis report, right? Also, don't forget to add upgrade packages that are not related to the Polkadot SDK packages, right? That's another like hint like we got. And another point is like, OK, once we upgrade the Polkadot releases, right, the Polkadot base, so we go from 0.943 to Polkadot version 1, all right? What's next? OK, we need to do our own release, our own like Trappist release, OK? So, simple, easy. We create the release branch, and we upgrade all the dependencies, having all this in mind. Then we check if there is any migration that that needs to be added to our runtime. Okay, so you go on the securities palette. There is a type for migrations. You add all your migrations there that needs to be added from the frame pallets, or even your own like migration pallets, and then you conduct the runtime. Of course, once we have all that, we run the benchmarks, and we sure like values like match with expected ranges, right? Let's suppose, I don't know, you run the benchmark, and one extrinsic goes like much more than was expected. That can basically break your processes. This is super important. Guys, this is super important. Try runtime, OK, before you do the release. So you basically try runtime is super nice because it says like if you have a missing storage migration, okay? So when we included this in our CI, the whole like thing started to make sense. And of course, if all the CI jobs succeed, we create a new release, we add a new tag, and basically what that happens is like triggers like a process, a job that builds the image in the Docker Hub. Okay? Then that Docker Hub is picked by Kubernetes and is basically deployed. Again, thanks to the DevOps guys for that. It makes our life much simpler. And a special mention is the command bot. So I don't know if, for example, you saw this on the PRs, right? Basically, you can invoke this command. It's a bot, and basically trigger some jobs on GitLab and calculates your benchmark and basically adds automatically on the WAV files, the resulted WAV files is already automatically put in the PR, okay? And this is very nice because this command bot is open source, so you can take a look and you can put it on your own processes, right? It's very cool. And once we have the release created, yeah, as I said, we have this action that builds the image in the Docker Hub. And then we have one action, right, which is basically calling the SR tool, which is a tool that allows you to create deterministic runtimes. And this is very cool because this allows us to basically put the runtime files in the releases. Like, we try to replicate what is happening or what was happening in Polkadot releases or common releases. Then the upgrade process consists on two stages, which is upgrading the collectors and doing the runtime upgrade. OK, this is like magic like Kubernetes is doing for basically burning the collectors images. And why we have that is very simple. We just do the runtime upgrade, right? So the last step was to, once we have the collectors that are in with the new version, what we need to have is at least two members, right, from the multisig that has the sudo, the root origin, to basically enact or authorize and enact the runtime upgrade, okay? And the very first time we did this, we disable, sorry, the lockdown mode, okay? And remember, when we started the network, all the transactions were paused or filtered, okay? And the first runtime upgrade, what we did was to first, of course, upgrade the code base, and then by calling like a sudo with the multisig, we disabled the lockdown mode. Well, this is like kind of how we did it, right, in the network. And yeah, this is done, right? Basically, this was the whole step like took us to basically become like a local testing, like a toy, parachain into like a real production-like parachain. So something like a bonus track, we are planning, as a project, we are planning to create a Trappist blog series where all this we are going to present it in very much details in the Polkadot forum, right? So we will have like certain articles where we are going in depth, and also we can raise any discussion right there, right? That's the beauty of the forum. Like you can bring also your own learnings. And yeah, basically that's it. Thank you very much.